Hi everyone and welcome back. Today we're going to look at Unit 3.4. This is called Proportional and Non-Proportional Relationships, and this is found on page 206 in the textbook. Alright, so we're going to kind of switch things up a little bit. This lesson kind of shifts us more over into what we're going to talk about for the next couple of lessons. So let's get started. So what we're going to learn for today, we're going to identify proportional and non-proportional relationships in tables and graphs. And we're going to identify proportional and non-proportional relationships in tables and graphs. All right, that sounds complicated. It's not. Okay, this is actually one of the really easy ones. Okay, not too much math involved. Okay, so identify proportional and non-proportional relationships in tables and graphs. Okay, then we're also going to describe a proportional relationship using an equation. Describe a proportional, oops, I didn't spell it right, there we go, proportional relationship using an equation. Okay. So we're going to describe a proportional relationship using an equation. Sorry, that looks really bad. That should be an O there. There we go. Okay, and go ahead and put your name at the top and your class hour and today's date. And let's get started. Oops. All right, number one, we're going to determine whether the cost of coffee is proportional to the number of pounds. If the relationship is proportional, identify the constant of proportionality and explain your reasoning. Okay, so what does proportional mean? Proportional means we get the same fraction each time. Okay. The biggest mistake that we have kids make whenever we get to this lesson is everyone wants to look for the patterns, because that's what you've been taught in the past, is how to look at a chart and find the patterns, which is great because that is important. However, the patterns that we look at are not always, that's not what we're looking at for today. It's, are they the same fractions each time? And fractions need to be in lowest terms, or at least equivalent if nothing else. Okay? So we're looking at, is the cost proportional to the pounds? So for this one, the first cost is $3, and that's what it is for 1. So 3 over 1, of course, is 3. Okay, then the next one is it costs $6 for 2 pounds. So 6 over 2. 6 over 2 is 3. So far it works. Okay, and then when it's going to cost us $9 for 3 pounds. So 9 over 3, that's also 3. And then we have 12 over 4, which is also 3. All right, so yes, this one is going to be proportional because the rate is constant. So yes, it's proportional, and I'm going to abbreviate here. Let's see, what else are we supposed to say? The rate is constant. The rate is constant. And then we're supposed to explain what that is. So the constant of proportionality is 3. Okay, and that'll be your answer every time today. So if it works, you say, yes, it's proportional, the rate is constant, and then whatever that is, and you tell me what answer you kept getting. So in this case, we kept getting the answer of 3, so then that's what we have. All right, so as you can tell, this is pretty different from everything else. How does it work with everything that we've been working with, though? It's because we're still finding that unit rate. Okay, because if I take 3 divided by 1, that's 3. 6 divided by 2, that's 3. 9 divided by 3, that's 3, and 12 divided by 4 is 3. So basically, no matter how much coffee you buy, are you paying the same unit rate every single time? And that's how the whole thing relates. Okay, I know it doesn't really fit in with the previous lesson exactly, but that's what we're doing here. Okay, let's try it again. All right, we're going to determine whether the number of legs are proportional to the number of spiders. If the relationship is proportional, identify the constant of proportionality and explain your reasoning. Okay, so we're saying, are the legs proportional to the number of spiders? So legs to spiders. So it's going to be 8 over 1, which is 8. 16 over 2, which is 8. 24 over 3, which is 8. And 32 over 4, which is also 8. So is it proportional? Yes. So yes, it's proportional. Let's do comma, and then we'll do and. Try to shorten it up a little bit. And the rate is constant. The constant of proportionality is 8. Okay? All right. Let's try it again. Example 2. Determine whether the distance is proportional to the time traveled. If the relationship is proportional, identify the constant of proportionality and explain your reasoning. Okay, so it's distance to time. So distance is 50 over 1. We know that's 50, so that's easy. Okay, and then we have 70 to 2. And that's going to make 35. So we can already stop there because it's not going to work. Okay, as soon as you find even one that doesn't work, then that's what it is. Okay, so this one is not proportional, so we call that non-proportional. And then we say the rates are not constant. The rates are not constant. Okay, and that's what it is each time. So either say, yes, it's proportional and the rate is constant, and this is what we kept getting, which in the last one was 8. This one was non-proportional, so you'll always say it's non-proportional, the rates are not constant. You don't it says explain your reasoning. Your explanation is that they're not equal, okay, or it's not constant, okay? So you don't have to explain, well, I got 50 and then I got 35 and all that. Okay, if you want to show it, you can just come over here and put 50 is not equal to 35, okay, and use that as part of your work, okay? All right, let's turn the page and let's continue on. All right, this time we're going to look at drinks and ice cubes. Okay, go ahead and pause it and try this one by yourself and come back to me just as soon as you're ready. All right, let's take a look. It says determine whether the number of ice cubes is proportional to the number of drinks. If the relationship is proportional, identify the constant proportionality, explain your reasoning. So we're doing ice cubes to the number of drinks. So we have 6 ice cubes for 1 drink, so that's 6. And then I have 14 ice cubes for 2 drinks, so that makes it 7. And right away we can say that these are not equal, so we can stop right there. So this is non-proportional. The rates are not constant. So it's actually faster when they don't work. Okay, all right, let's move on to part 3. All right, so let's look at example 3 here. This is the second part of the objectives, which is to describe a proportional relationship using an equation. All right, so we're going to have to come up with an equation here for this one. It says a circle's circumference is proportional to its diameter. Okay, so that means you would take the circumference divided by the diameter. Use the figure to find the constant of proportionality. Then write an equation relating the circumference of the circle to its diameter. What is the circumference of a circle with a 6-inch diameter? All right, so we got lots of different parts here. So first they want us to figure out what the constant of proportionality is. So for this one, it tells us that the circumference is proportional to its diameter. Okay, well, what was the circumference? It tells us in the figure that the circumference was 12.56 meters. So we're going to put 12.56 over, and then the diameter, which is all the way across, is 4 meters. Okay, remember, diameter means the entire length of the circle going across. Okay, you should have had that in previous years, but if not, that's what it means. Diameter is all the way across. All right, so let's figure out what that is. Well, we're going to take 12.56, divide that by 4. So go ahead and grab a calculator if you need to. Pause it and go get one. And what do you come up with? You come up with a very, 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 very long number, right? Yes, maybe? Or did it terminate? Let's see. Nope, it terminated. Okay. They gave you the easy version. Okay, so what we came up with was 3.14. All right, and if you're in my actual class and not out there in YouTube land, okay, we've talked about this number before. Okay, this is the number pi. All right, pi is approximately 3.14. Okay, and then it keeps going from there because you guys have seen my poster and you ask me all the time, like, what is pi? And da-da-da-da. All right, well, pi is not something that they just made up. Okay, what happened was when they were figuring out how math all worked, okay, they kept taking the outside of a circle, which is the circumference, and they kept dividing it by the diameter. They kept getting the same number every single time, and they're like, oh, well, this is weird. Okay, so that's how they found the number pi. Well, because it goes on forever, they just call it pi. All right, they don't want to call it 3.141, da-da-da-da, and so on. All right, so they just give it a Greek letter, which is pi. So they actually found it. It's not just something they made up or decided to call it one day. They actually found it by doing this over and over and over. And it happens with every single circle. Okay? You could take the top of a can of soda, measure their circumference as close as you can, and divide it by how far across it is, and you're going to get extremely close to 3.14. Okay? Just because it has to be an exact measurement. So you may be off by just a little bit, but you should kind of figure out what the same thing is. Okay? You can grab a roll of paper towels. You can do the inside circle or you can do the outside circle. You take the outside, divide it by what it is across, and it will come out to 3.14 every single time. Okay, we call that pi, all right, because it's proportional with the circumference and the diameter. Okay, so now that we understand what that is, we need to write the equation. So 3.14 is the constant of proportionality. So in order to find the circumference, which is c, what we have to do each time then is we have to take 3.14 and we have to multiply it by the diameter, right? Isn't that what we just said? So that's what we're going to have to do every single time then to figure out the circumference. We divide them going forwards. So if we're going to go backwards, which, well, actually dividing would be backwards, multiplying would be going forwards, whatever. But that's how it would come out. Okay, so circumference equals 3.14 times your diameter. Okay? Now they want us to use that. Okay, so this is the first answer. So let's see. Okay, so this is one answer here. This is an answer. And now they want us to use what we just got, which is c equals 3.14d, to figure out what would happen if we had a 6-inch diameter. So let's try it. So if I take the circumference and put it equal to 3.14, which is pi, all right, and then times it by the diameter of 6, what do we end up with? So let's try it. So let's take 3.14 and times that by 6, and I come up with 18.84. 18.84. All right. And it is in inches, so this would be inches right here. Okay, so this is my other answer. All right, so we're going to have multiple answers for some of these. Okay? All right, number 3. Down the got it question. Let's try that one. Go ahead and pause it and try it on your own. Okay, it says the cost for 2.5 pounds of meat is $7.20. Find the constant of proportionality, then write an equation relating cost to pounds. How much will 4 pounds cost? All right, so again, this all comes back to like the other day we had, we would divide to figure out, like what the miles per hour was or whatever, and then we had to figure out how many that was going to take in like 7 hours or whatever that one question was. Okay, this is the same thing that we're doing here. We're trying to figure out how much one of something is, and then we're going to multiply that by how many we actually need. Okay, so we're going to have 2.5 pounds of meat, and it's $7.20. We're supposed to find, let's see, we need to do cost to pounds. So cost will go first, so that's $7.20 over, and then we know 2.5 means 2.5. So let's just use a decimal here to make it a little bit more math friendly for us. Okay, so 720 divided by 2.5 is going to give us 2.88. Okay, remember that's money. Okay, so it's 288, and that's going to be per pound. Oops, is there a P? P's not pound. There we go. 288 per pound. Well, now they want us to figure out to write an equation to show how much it would cost for any amount of pounds. So if I know that it costs 280 for just 1 pound, how could I figure out then what it would be for any amount of pounds? Well, I would just multiply, right? So if I'm finding cost, so let's use little c for cost, my cost will be 288 per the number of pounds, right? So there's my equation. Now we're going to use that equation to figure out how much it's going to cost for 4 pounds of meat. All right, so let's say we're at the deli and we need to get some turkey for this weekend or whatever's going on. Okay, so let's figure out what that would cost. Well, if it's $2.88 per pound and we need to buy 4 pounds, then to find my cost, I would simply take $2.88 times that by the number of pounds, which is 4. Okay, and $2.88 times 4, let's type that in. That's $11.52. So my cost is $11.52. Okay? We use this kind of math all the time. Okay? If you ask your parents, okay, they'll probably tell you it's like, you go to the grocery store and you buy meat out of the meat section and all that stuff. Okay? You'll see on there, it'll tell you how much per pound it is. All right? And then from there, you got to figure out how much is in the package. So most of the time they weigh it for you ahead of time, and it says in there like this costs, in this case, $2.88 per pound. Well, there's 4 pounds inside of here, so when you go to the register, it's going to cost you $11.52, and then of course you still add on tax, but it's still $11.52 just for the food. Okay, so we do use this more probably than anything else math-wise than some other things. So I know some people are like, well, when are we ever going to use this? This we use all the time. Okay, we really do. So, like we just, like here, well, I'm recording this on, it's December 30th today, so we just got done with Christmas and stuff, so at my mom's side, we always have usually like kettle beef or ham or something like that, so we have to figure out how much it is per pound, okay? Then we got to figure out how many pounds we're going to need all together and see how much that's going to cost. So sometimes we do kettle beef, sometimes we do ham, okay? It kind of depends on how much money's in the budget for everyone, and we kind of have to go from there. All right, so we really do use this a lot, especially when we're buying groceries, obviously, and other things too, but more so for groceries probably than anything else. Okay, sorry, I had to steal a drink real quick. I just had lunch. So that's it for today. It's a super short lesson, as you can tell. Take your time, rewatch if you need to. Give me a like and subscribe, and I'll see you later. Thanks, bye.